morning, everyone. Like Andrea mentioned, my name is Andrew Polk. I am the lead marine meteorologist for DTN, and we'll go over this webinar together this morning. So the goal of this webinar today is to empower you with intelligent and actionable weather insights for 2021 tropical season, as well as the upcoming monsoonal transition period that we're expecting this spring into the summertime. As mentioned, the topics for this morning will include a review of last year's tropical season, along with a look into the details for the monsoon season and into the tropical activity for the North Indian and the West Pacific basins. Let's begin our discussion this morning with a look at the monsoon season and what we expect for that transition of the monsoon. Throughout each year, the monsoon evolves from season to season, largely due to temperatures present over the continent. So that would be over India as well as Southeast Asia. During the wintertime, cooler temperatures over northern India and Southeast Asia lead to that high pressure being in place, as you can see on the left-hand side here. And with that high pressure, generally that develops that offshore flow from the continents into the region. So that is the primary driver for the northeasterly monsoon in the South China Sea, as well as that northeasterly flow that occurs during or in the Arabian Sea during the winter time. Now, as we transition throughout the spring, that high pressure is replaced by low pressure once those temperatures over India and Southeast Asia begin to increase over time. This typically leads to some light and variable conditions across the region during that transition period. And then once that low pressure or warmer temperatures are in place, that's when we develop that more southeasterly flow over the Arabian Sea and more of a southeasterly flow as well throughout the South China Sea. So with that primer on the monsoon evolution throughout the year, what do we expect for it to occur this year? Typically, for the Bay of Bengal, we see that transition period to occur in late May through early June in any given year. And as that monsoon kind of progresses to the northwest, it reaches the Arabian Sea in the early June through mid-June timeframe. On the right-hand side here, we do have our forecasts for our temperature anomalies from April through June. And we are expecting for there to be warmer temperatures than average across India, especially northern India, where the primary low pressure for the monsoon is expected to set up and typically sets up from year to year. So with this upcoming season and those warmer temperatures forecast with these anomalies in place, it does support for the possible development of that low a little bit sooner than usual. And with that, we're expecting for this monsoonal transition to potentially occur sooner than we typically see on a normal year. One other key driver for the monsoonal evolution is the high oceanic heat content to the east of the Philippines. There is some research out there that does suggest that the high heat content in the West Pacific does connect with an early onset of that monsoonal pattern. Both in the Bay of Bengal and into the Arabian Sea. And you can see from on the right-hand side our current ocean heat content. And it has there's a very high ocean heat content present to the east of the Philippines. So we do see that signal for those warmer waters, that higher energy to be present in the waters, which is that key connection to the early onset of the monsoon across the region. So with the above average or with the above temperatures from May through June that we looked at in the previous slide, along with this high ocean heat content in place already, all of that points to an earlier onset of the monsoon for this upcoming season. Turning our attention to the overall potential for tropical seasons this upcoming year, it's prudent to take a quick recap on what we saw in 2020 of last season. So last year in the West Pacific specifically, it was a slightly below average season which was likely due to a fairly slow start to the West Pacific season. We didn't see as many storms early on, but the storms returned to more average as we progressed into after the August timeframe. Overall, we had 23 named tropical storms in the basin, 10 of which became typhoons and 2 super typhoons throughout the year. We also had just to highlight a few of the more significant typhoons that did occur last season. Typhoon Vongfong was very early in the tropical season, and it occurred during the month of May from May 8th through May 18th. It was a fairly slow-moving storm and struggled to get organized initially to the southeast of the Philippines, but soon it organized fairly quickly and then tracked westward over much of the Philippines and then towards Taiwan. So the primary impacts of Vongfong were to the Philippines and Taiwan largely. It had estimated maximum sustained winds of 85 knots or 155 kilometers per hour upon landfall in the Philippines, and actually ended up resulting in estimates of upwards of $50 million in damages. And because of the impacts, this was officially retired by the World Meteorological Organization. The last typhoon of the season was Typhoon Vamco, and it brought additional impacts to the Philippines and then into Vietnam. You can see that there was a slightly different track for Vamco when compared to Vongfong, as Vamco took a more westward track across the South China Sea. It had very similar winds with the peak intensity in the South China Sea itself before impacting Vietnam of 85 knots with 155 kilometer per hour maximum sustained winds. Overall, all damages to both the Philippines and into Southeast Asia, it totaled up to around $1.06 billion in damages, leading to Vamco to be officially retired as well. So that was just a quick look at some of the activity that we saw in 2020 in the West Pacific. Turning our attention to the North Indian, where in contrast to the West Pacific, the North Indian actually had a slightly more active season last year than is typical. We had 6 tropical storms or deep depressions, and then we ended up having really one major storm occurring with severe, with super cyclonic storm Amphan that occurred in the Bay of Bengal. And that was really what drove up the damage estimates that we saw throughout the ocean basin for this year. So let's take a closer look at Amphan, since it was the most significant storm of the season. It did occur in May, so between May 16th and the 21st. And you can see that that time frame is exactly in that time frame of the transition period of the monsoon, which is why getting the timing of that monsoon is so important. It is really a key indicator for some of the tropical activity that may occur. Amphan last year was the strongest tropical cyclone to impact the Ganges Delta since 2007, and damage from the system was the costliest for a single storm on record in the North Indian Basin, leading upwards of $13.1 billion. And in total, the whole season was around $15 billion. So Amphan really contributed to that overall total. And it became a Category 5 system on the Saffir-Simpson scale with estimated sustained winds of 140 knots. So clearly we had a fairly active year, at least with Amphan in the North Indian, and then that slightly below average year in the West Pacific. But what can we expect for our next tropical season to hold here in 2021? Historically, across the North Indian, we have 2 peaks in the tropical season when that monsoonal transition occurs. The first is from April through June, and the second is from October through December. So that springtime and then autumn time frame for the North Indian Ocean. In contrast to that, the West Pacific is actually somewhat considered a year-round season, as you can get a tropical system pretty much any time we have a recorded tropical cyclone or a recorded tropical storm in pretty much every month of the year on record. However, the core of the season really begins in May and ramps up into the August and September timeframe before it begins to decrease as we get into December. So what are some of the key factors that we're looking for when we are making a seasonal outlook for tropical activity? There are really three things that we really cue in on for a possible enhancement of tropical activity. The first is the warm sea surface temperatures. Warm waters really provide the fuel for a tropical system to develop and become established. So anytime we see those warmer waters, we can expect for there to be an above average season in the area. The second is our vertical wind shear. Weaker vertical wind shear allows for thunderstorm activity associated with a system to band and really become better organized, allowing for a tropical system to become an established tropical system as it progresses forward. And lastly, we're looking for large scale rising air motion to be present. And that large scale motion really allows for that moisture over the ocean to be lifted into the atmosphere, providing additional fuel for a tropical cyclone to develop and intensify as it progresses. So with that being said, we have a few seasonal drivers that we're looking at for this season. We have a neutral ENSO phase that transitioned out of La Nina, which was in place last year. We have colder Arabian Sea, a slightly warmer ocean temperatures in the Bay of Bengal, and then a warmer West Pacific. The main story with the neutral ENSO phase that we're expecting for this upcoming season is that it is actually a transition period out of the La Nina pattern that we saw last year. So just a quick reminder is La Nina, we typically see warmer waters in the Central Pacific with the La Nina. And as we have transitioned out of that ENSO phase, those warmer waters continue to progress to the west and have filtered into the West Pacific currently and is expected to remain into this upcoming season. So we are expecting for that transition from La Nina to this neutral ENSO to bring about above average sea surface temperatures across the West Pacific. Additionally, we have what is called a negative phase in the Indian Ocean dipole, which is what is driving the colder Arabian Sea ocean temperatures and the warmer temperatures in the Bay of Bengal. One thing that negative phase of the Indian Ocean dipole is also driving is typically in that negative phase, we have sinking air in the Arabian Sea, so in the western part of the Indian Ocean. And then that leads to rising air or that large scale ascent into the Bay of Bengal, and that also carries over into the West Pacific, specifically to the east of the Philippines. So the interaction between that large scale rising air motion with the warmer sea surface temperatures in the West Pacific should lead to some increased convergence and convection as well, and will lead to that more enhancement of the possible tropical activity in the region. Just another look at our sea surface temperatures currently that's in place is the latest indicators show that we do have that warmer waters in place across much of the West Pacific as well as the Bay of Bengal. And you can actually see some slightly cooler waters there in the Arabian Sea, which we expect to carry over throughout much of the season with cooler than average temperatures. So overall, our forecast, again, with that neutral ENSO and that negative Indian Ocean dipole, we're calling for those warmer sea surface temperatures to be in place across much of the West Pacific. And we're actually calling for a lower vertical wind shear to be in place throughout the entire region from our June, July, August forecasts here. So on the right-hand side, that June, July, August timeframe is our wind shear expectation for this upcoming season. And we can see those values are lower than average across the area. So that will allow for any tropical activity that is trying to organize and develop has a better chance of doing so with that lower wind shear tendency across the region. Shifting focus to the North Indian, we are expecting for a more average season to be in place, with the focus primarily on the Bay of Bengal. The reason the focus is on the Bay of Bengal rather than the Arabian Sea is the Bay of Bengal is expected to have fairly average sea surface temperatures, but with that decreased wind shear, that should allow for systems to organize a little bit better. And then coupled with that North Indian dipole of that rising motion across the Bay of Bengal should allow for more convective activity to occur and allow more chances for a tropical system to become established and more well developed. In contrast to that, the sinking air in the Arabian Sea is really suppressing development in that region is what we're expecting for this upcoming year, along with some cooler sea surface temperatures across the region. Lastly, let's take a look at the rainfall anomalies. So again, this really points to that large scale rising motion with that negative phase of the dipole. We can see fairly average precipitation in the western part of the North Indian Ocean in the Arabian Sea, and that is where we have that sinking air present. In contrast to that, we have rising motion over the southeastern Bay of Bengal, leading to an expected above average precipitation and rainfall in that area, which leads to that thunderstorm activity associated with tropical activity. Looking further to the east into the West Pacific, you can see to the east of the Philippines and the south of Japan, we do expect for higher rainfall anomalies to be in place due to those warmer sea surface temperatures, but also, again, tied to that the negative phase of the North Indian dipole with rising large-scale ascents present even into the West Pacific. After looking at all of those seasonal drivers, what do we expect to occur for this upcoming season? This is a look at our initial forecasts for 2021 across the North Indian. Like I just mentioned, with all of those factors in play, the sinking air and cooler waters across the Arabian Sea, we're actually looking at that reduced risk to be present throughout that region. However, in contrast, we expect for an elevated potential in the Bay of Bengal with the above average precipitation, average sea surface temperatures, and that lower vertical wind shear in place. All of that combined collectively, we're looking at about an average season with our initial forecasts, looking at a total of 5 tropical storms, and we average around 5.5, with 2 of those storms being severe cyclones and 1 super cyclonic storm expected, with the primary focus being on the Bay of Bengal, although that does not completely rule out a stray system potentially occurring in the Arabian Sea. Shifting our attention over to the West Pacific, with that transition from the La Nina phase last year into the neutral ENSO phase, we do expect for there to be above average convection, for those sea surface temperatures to remain above average through much of the season, and for that large scale rising motion to be in place across the area, leading to an elevated potential across much of the region. The one main area that does not have elevated potential would be the South China Sea, but that potential is average and is a fairly common place for tropical systems to occur. So just because the South China Sea is not in this elevated potential area, we still expect for there to be at least some activity, fairly average activity across that region. All of that combined, we're looking at a slightly above average season for the West Pacific with 28 tropical storms to be present, with 17 of those becoming typhoons and 10 of those becoming intense typhoons. So category 2 and above for that typhoon estimation. So as expected, or here are some of our key messages, just wrapping up our time here spent looking at the forecast for this upcoming season. We do expect for that earlier onset of the monsoon transition to occur with the warmer temperatures over India and the high oceanic heat content east of the Philippines. We're expecting for favorable conditions for tropical activity in the Western Pacific Basin due to the above normal water temperatures and the reduced wind shear. And then into the North Indian Ocean Basin, we're expecting for a reduced impact in the Arabian Sea due to the cooler sea surface temperatures and the sinking air, contrasts with that above average expectation in the Bay of Bengal with that rising motion, average sea surface temperatures, and low vertical wind shear. But again, just placing emphasis on even a weak tropical system can have significant impacts if it strikes a more vulnerable location. So, continue to be aware of tropical storm development into this upcoming 2021 season and refer to our DTN products that we produce on each system as we progress into the primary core of the season. So with that, I will open up the floor to any questions that anyone might have regarding either the North Indian or the West Pacific regions.
I do see one question coming in. It says, how are things looking in the next couple of weeks for the North Indian Ocean? Any activity to already start being concerned about?
Yeah, so I actually looked at the Bay of Bengal earlier today with the previous forecast runs, and over the next 7 to 10 days, we're really expecting for that potential to. We're not expecting for there to be any development in play over the next 10 days or so. We do see some signs of some increased moisture, especially in the southeastern part of the Bay of Bengal. So that is something to watch for. That as that transition in the monsoon begins to occur, here as we go into the month of May, that could allow for some of that convection, some of that precipitation to become better organized and allow for that potential to develop. We have started our North Indian tropical planners across the region. So if you are a subscriber to those North Indian planners, be sure to keep an eye on that planner as we go throughout the days here. And that should really highlight any key systems that might develop into a tropical cyclone as we progress forward through this transition period of the monsoon.
That is the only question that I see that has come in.
All right, very good. Well, thank you so much. And with that, I will pass things along to Ryan and Fulton to discuss our some of our tropical products and some of the key features that you can utilize with DTN service.
All righty. Yep. Thanks, Andrew. Actually, I 1 second though. I do see a question just popped in. At least I see the symbol. Can't see the question just yet. So Andrew, is that something that you can see?
Yeah, it just says thanks, much appreciated.
Oh, okay. That's good. Yep, so we'll go ahead and jump into an overview of the tropical products. And what'll be pretty nice about this too is I'll be able to show it from the vantage point of an actual system. We'll go through a case analysis of one of the cyclones that Andrew covered, Amphan, from May of last year in the Bay of Bengal. So we'll go ahead and start with an overview of the services, and so what this is really geared to provide is this step-by-step staged capability. And this is consistent in any basin around the world. So we provide this in the regions off of East and West Australia, West Pacific, the North Indian, the North Atlantic, et cetera. And so these tools are consistent. So our clients that are globally operating, they see the same consistent type of information no matter where they operate. And so the way it works is that throughout an entire tropical season, we start off with a tropical planner, a daily tropical planner. This is a 7-day look ahead. and highlighting any potential for formation that we expect across the basin. And then there's also some visual guides to help with anything that's active. It's just kind of a quick cheat sheet for any active system. But really the purpose of this planner is to give you that 1 week look ahead of anything that could potentially be stirring that's worth paying attention to. Then once it reaches a minimum threshold for probability of forming, we begin issuing our own significant tropical disturbance advisories. So these are well before what a local government authority, any of the WMO, World Meteorological Organization, regional centers, these local authorities will issue. Some would look towards the Joint Typhoon Warning Center. Others would look to the JMA or IMD, or if you go down to Australia, the Bureau of Meteorology. But typically, we're getting these advanced advisories out days and multiple days ahead of those advisories in order to be able to make the necessary decisions in advance. That typically, if you wait, you no longer have that window to be able to react. So we're doing those, and then once a storm is officially classified by those government authorities, we switch over to an active storm advisory, where we provide a full detailed briefing, and we'll show an example of that. Now, once a storm reaches this point where we begin issuing our significant tropical disturbance advisories, we then also will issue site-specific tropical decision guidance. And that would be for a forecast track or a worst-case scenario. And I'm going to go over a few examples of different report types that we have for different use cases, whether it's someone who works offshore, operates offshore, or on the coast or inland, different reports for different flavors. So we'll go ahead and go into that case study and look at tropical cyclone, super cyclonic storm Amphan from last year. Apologies that this is an animated GIF, so it was supposed to look really cool, animated as it had rapid intensification on the 17th of May. So you'll just have to take our word for it that the satellite imagery is very impressive. So the storm officially, this is what is probably the key thing to keep in mind here, is that it formed on the 15th of May. So the day that official bulletins started being issued. That's when our active storm advisory started being issued, 15th of May. A couple of days later, it went through a rapid intensification where it ballooned to peak wind speeds of 140 miles per hour or 140 knots. Extremely strong storm, and intensified very, very rapidly. It was quite an impressive feat over just the course of 24 hours. And as Andrew described earlier, made landfall on the 20th. And about 13 billion in damage. But one interesting fact I saw was that 2008 Storm Nargis, if I'm pronouncing that right, in today's dollars was slightly more damaging at 15 billion. So it's a bit of an interesting point. And when it was at its max intensity, the storm was at 920 millibars, so very deep, low pressure system. So what we started doing, as Andrew mentioned, we issue our daily tropical planners every day throughout the season. And so as this date was approaching, we first were seeing a hint of a system forming on the 9th of May. That's when it was more than just a random possibility, some random noise in the model data. We saw it as something that was tangible in the evidence. Indeed, in our proprietary cyclone probability analysis, we could see a 30–40% probability of a formed cyclone 6 to 7 days out in the Bay of Bengal, which ended up being right on the mark later on. So on the 9th of May, we were highlighting, okay, we've got this invest area, short for investigation area, and there would be a 30% chance of development potential in that 7-day horizon. And then our forecasters provide a briefing of why they believe that there's this potential for formation, what are the scenarios of how this could play out? What are the different models indicating versus how the models are comparing against reality? So just very helpful commentary from the forecasters here. And then we break down chance for development at different intensity levels and a forecast of what one of those models might be outputting. So this was 6 days ahead of the storm forming. Then we fast forward 48 hours to the 11th, and this is when, consistently the models were showing this formation, even though it was not even really a puff of clouds coming off of, really it originated out of the South China Sea and the Gulf of Thailand and crossed over. So looking at this, our forecasters, we made that judgment that we wanted to go ahead and begin issuing our significant tropical disturbance advisories. And in retrospect, this ended up being roughly a full 5 days ahead of when the official government entities out in the region began issuing their bulletins on this system. And so our forecasters detailed a 5-day track, showed that, yes, we expect there to be formation, but pretty much at the tail end of the forecast period of getting to a level where a cyclone would be declared, which was pretty darn close to what ended up happening. And then on a subsequent page, further details of that threat, just as we covered a moment ago. And 2 days later, more evidence was pouring in that this was a good potential of a system that was going to form. And then now we jump ahead to an example of many days later, the storm was declared. We are now issuing tropical cyclone active storm advisories. And the details here are far more thorough, where the forecasters will provide a full detailed analysis. This would be on the second page of the report, where we break down both impacts for offshore companies. So we have clients in offshore oil and gas or construction, wind, shipping interests. These would be particular impacts for you, and then onshore impacts for everyone at the coast inland. We break down those kinds of impacts and where the expectation of those impacts would be. And then over here, also important is the synopsis and the commentary from the forecaster, just understanding how is the storm progressing, how are the models projecting both its track and its intensity, what are possible scenarios that could play out. So it's definitely kind of a first stab of proactive consultation that's provided right into the report. And then our clients have the ability to then call into the meteorologist to seek additional guidance. That's included with all of our services, the phone number being on every single report down here at the bottom. Or if an email was more convenient, you can just reply to the report's delivery to ask a question. So we had those active storm advisories all the way through to landfall. And I mentioned earlier about site-specific guidance. So this is the first example of one of those reports. We call these the tea time reports. What this allows an operator to do, and these are primarily used offshore. Many of the decisions made for offshore, either evacuation or perhaps not an evacuation of the asset, but taking the asset off location and evacuating to a safe location. Decisions need to be made with a minimum amount of time before arrival of gale force wind speeds. And these reports allow that particular end user to include their preparation time, that tea time of that countdown of how much time is needed. And then what the tool will do is based on the forecast path, which would be right down the middle of the forecast cone. And then also for the direct path, so you see the direct path guidance there in blue at the bottom, a calculation if the storm were to just go straight at your asset. If the forecast was just completely wrong, and you want to prepare for the absolute worst case scenario, which would be a direct path. The calculations are made accordingly based upon that path. So it gives you how much time is remaining, that's decision time remaining. In the case of this example, the direct path, it's already 33 hours past due. The decision would have to have been made over a day prior. And these reports begin being issued as soon as we issued tracks. So there would have been some other reports that were issued far earlier than this as well. But as you can see on the forecast decision guidance, this storm is expected to stay well away from this location. So everything is marked as a not applicable, and the closest point of approach of the storm is 302 nautical miles. That's an overview of a T-time report. Now, what we do is provide all of these reports in a single location format or a multiple location format. So if you have across your basin or across your entire regional operations, many or dozens or hundreds of locations, they can all be captured in a single report in a nice condensed matrix. So all of those same decision points are broken down in a single table for the forecast path, and then there's a table on a subsequent page or pages for the direct path scenario. So that's one nice thing too, if the operations you have are very widespread and you have a lot of different assets that you're looking after. And then, so we just talked about a good offshore case. The next report here is called a threat report, and these are primarily used for coastal or onshore locations because the focus is on wind, storm surge, and precipitation impacts. So at the top, at your location, you would see a 10-day breakdown of the wind speeds at that location. And I know it's a little blurry, but within the table here, you get a breakdown of the maximum intensity based on the forecast, how much rainfall is expected, and then also the expected storm surge at the location. And of course, that has to be a location within a narrow distance from the coast. But if you're on the coast, you would get a storm surge forecast there. And then the table at the bottom has standard wind fields that are typically used for decision processes. So either 39 miles per hour or 34 knots. Then we've got 58 miles per hour or 50 knots, and then 74 miles per hour or 64 knots. And those then are broken down for that forecast path of how many hours you have until arrival, when it's going to happen, how long it will last, and then also the direct path scenario, that worst case scenario. And then all of the same data is broken down in a detailed table on subsequent pages. So if you want a little bit more detail, what you're seeing in the graph, the table is there to give you that more concrete hour by hour breakdown. And just like the T-time report, the data can be broken down in a multiple site report to see across an entire fleet or an entire regional set of operations if you've got coastal port facilities, whatever that may require. And all of those same points of information we just went over broken down in a nice condensed matrix where every location is on one row. And then finally, the last report type that we have is called the risk and response report. And what this is geared for are companies that have very complex, multi-tiered contingency plans where, say, phase one is that a storm is within a certain distance or a certain amount of time from our location, and the wind speeds are going to be greater than a certain amount, and so on. And so each phase, you have a certain defined criteria that your organization follows to know whether you move to the next phase, which requires a different group of individuals, perhaps to be evacuated, non-essential personnel, or even you get to a later phase, the essential personnel. You can actually program those particular thresholds, those decision points into the report, and then it will very quickly tell you whether you've reached that particular phase or not, and when it's estimated that you will reach that upcoming phase. If it's not expected that you will reach a phase on the entire forecast, then it'll just put the hash for not applicable. I think this storm here was a tropical storm, so in the case of this location, there wasn't a whole lot of impact. But it was a very good example that we felt was pretty good to pull because it had a lot of very particular rules where they use for thresholds for setting those phases for what to do at each particular level. So I liked this one as an example from a customer that was in inland USA in the state of Texas. And then finally, I don't think I have an example, but same as the other reports, there is a multiple location version of the risk and response report. So single site or multiple location. And then finally, many of the organizations that we work with a company called Esri and utilize their ArcGIS geospatial intelligence platforms. And one of the things we definitely like to share is that all of our information is integratable into that system. We are a silver partner of Esri, so all of these tropical layers that you've seen visualized are available as a data service that can be consumed by all of your users. And then in addition, we've had a number of customers take it a step further, and all of these reports that we've just gone over that are delivered via email, they've configured it to where the end users can pull up these reports within the ArcGIS applications directly, because we have an API that can deliver these reports directly to an application. So that's the note here about the weather ops reports being available for API integration. So for those of you that are Esri customers, this is certainly something that to further enable and improve your company's ability to leverage and get the best out of that investment with Esri. This is just another data service that you could consider to improve that status there. And so I believe, yep, that wraps up the elements that I was going to go over here, and I will open it up now to any questions.
Thank you, Ryan. If you do have any questions, feel free to put them in the Q&A section on the right-hand side of your screen.
Okay, I do have one here.
Great.
Simple one. Do you have a mobile app? And I assume that would be to access this information. The answer is yes. So as you've seen, these reports are called weather ops. So if you are a weather ops subscriber, part of that system, in addition to getting these reports that are deliverable via email, a mobile application is part of that platform. There is a web and a mobile application that's part of that system. The web application actually is pretty important because it allows you to be able to manage your distribution lists, your locations. It really allows you to be able to control that all yourself directly. And then the mobile application is a way for you to be able to access all of this information on the go. So it has the tropical tracking, has copies of the reports, has the ability to share information. You'll get push notifications whenever reports are generated for your location. So yes, that's all part of that mobile app. And then I think, let's see here. I think I need to collapse my chat. There we go. Now I can see the questions coming in from the Q&A. So the next one is, do you integrate this data to the SPOS software? The answer is partially. When SPOS is showing you the tropical forecast for a particular storm, the track, the information. In fact, I'll kind of jump back and show like this example here. this tracking information, all of that is coming from our system. So it is integrated partially into SPOS. If you want to take it a step further and acquire these types of reports here that have the more detailed consultative information, those ones we would need to set up as an additional service that you could get through email. Pretty much the easiest way to answer that one. And if that's something you'd like to look into or try out, definitely contact us through. You can either contact us through the links in the webinar that you've been receiving via email, either the invitation or the follow-up that's going to be sent out, or if you have just a direct line with your account manager at DTN, you can start there too, and we can walk you through real easily how to obtain this additional information. It's a good question about SPOS. And then I have another one here coming through chat. Can you get wave height information as well as wind speed in the threat forecasts? And so the examples that we saw were focused mostly on wind speed. That's the key trigger for most of those threat reports. But you saw on the threat report, it also included storm surge and precipitation in those reports. But for offshore locations, when it comes to the wave height information, we keep that on the standard daily forecast. So the same wind information that's coming through on these site-specific tropical reports, that same wind information is also on your site-specific daily forecasts. And that's where you're going to have your wave forecast information that's particular to that location. So and with weather ops, you can acquire just the tropical services standalone, or you can acquire the more comprehensive set of weather ops, which includes daily forecasts, whether there's tropical weather or not. It gives you your wind, your wave, your weather conditions, etc. Looking 7 or 10 days out. Those can be part of the system that you get on a regular basis. All right. I'll go ahead and ask one more time for any last questions. Okay. Yep, Andrea, I'm not seeing any through the chat or through the Q&A.
And neither am I. All right. Well, I want to thank everybody who was able to join us this morning for our webinar. I want to thank Ryan and Andrew for going over the forecast and how our DTN products can help you in this upcoming season. So with that, we will end our webinar. Thank you and have a great rest of your day.